Joe Rogan, Oumuamua will make direct impact in 2 weeks and it's not stopping. Tesla and SpaceX's CEO Elon Musk disclosed something truly alarming. The enigmatic space object named Oumuamua will make a direct impact in 32 hours. But where did this entity originate? What will occur if this colossal object, hurtling at incredible velocity, collides with Earth? And how can we prevent it? But above all, can we endure it? To grasp the complete picture, we must comprehend what this object truly represents. An enigmatic story, the discovery of Oumuamua. Back in late 2017, astronomers stumbled upon a captivating celestial traveler zooming through our solar system at an astonishing speed. This interstellar visitor was dubbed Oumuamua, a name drawn from the Hawaiian language, signifying scout or messenger from afar. The nickname aptly captured its role as the inaugural confirmed object from beyond our solar system to venture into our cosmic neighborhood. Now, what exactly is Oumuamua, and why is it causing such a stir? Its origins remain shrouded in mystery, and its elongated, cigar-shaped form, along with its unconventional behavior, sets it apart from the typical celestial bodies we're accustomed to observing. This enigmatic object spans several hundred meters in length but is only about 40 meters wide, making it significantly more elongated than any regular asteroid or comet within our solar system. The intrigue doesn't end there. As Oumuamua made its journey away from the Sun, it exhibited an unexpected acceleration, deviating slightly from its anticipated trajectory. While some scientists proposed natural explanations like outgassing or solar radiation pressure for this phenomenon, others entertained more exotic possibilities, including the tantalizing notion that the Oumuamua might be a slender solar sail-like probe, dispatched by an advanced extraterrestrial civilization hungry for information. Where is Oumuamua now? How does its behavior influence our understanding of space? Let's explore the details. Astronomers worldwide turned their telescopes towards Oumuamua during its visit, hoping to unravel its secrets. However, its swift pace and brief appearance in our observable region limited our ability to scrutinize it closely. Yet, the data collected during this passage provided valuable insights. Spectroscopic analysis revealed it has a reddish hue, indicating the presence of metal-rich minerals on its surface. This suggested a potentially rocky or metallic composition. Though the specifics remained unknown, Oumuamua's rotation added another layer to the puzzle. Tumbling once every 7.3 hours, its brightness fluctuated dramatically. This peculiar behavior, coupled with its non-uniform surface, fueled speculation within the scientific community. Some argued that it couldn't be a run-of-the-mill asteroid due to its elongated shape and rapid rotation. Furthermore, the absence of a visible coma or tail, typically associated with comets, raised eyebrows. Comets usually release gas and dust when approaching the Sun, creating a visible tail, yet Oumuamua displayed none of these customary cometary activities. Perhaps the most disturbing element of this was its unexpected acceleration. Gravitational forces alone couldn't account for the acceleration of the Oumuamua, leading astronomers to ponder whether solar radiation pressure might be propelling it. While this phenomenon isn't unheard of, the magnitude of Oumuamua's acceleration exceeded expectations, prompting serious contemplation about its true nature. Intriguingly, this celestial body's departure from the norm adds fuel to the idea that it might be an artificial object engineered to endure the rigors of interstellar travel. Why the Oumuamua might be an alien spacecraft. One of the most captivating aspects of the Oumuamua is its intergalactic trajectory, marking it as the first known interstellar object to venture into our solar system. The odds of a natural intergalactic object following just the right trajectory to be observed in our solar system are extremely slim, prompting some to propose the idea that Oumuamua could be a probe or spacecraft from an advanced alien civilization. Now, imagine for a moment if Oumuamua is indeed an alien spacecraft. This would be a groundbreaking discovery with profound implications for our understanding of the universe. The notion of an advanced alien civilization capable of intergalactic travel raises a myriad of questions about their technology, motivations, and whether they might be actively monitoring or exploring other star systems. However, scientists have been diligently exploring natural explanations for Oumuamua. One compelling theory suggests that it could be a fragment from a comet or an asteroid, possibly originating from a larger celestial body within another star system. Comets and asteroids, remnants of early planetary formation, often break apart due to collisions or gravitational interactions. In Oumuamua's case, this theory proposes that it was once part of a much larger comet or asteroid, ejected into interstellar space through some violent cosmic event. As Oumuamua traversed our solar system, it displayed some peculiar characteristics, such as non-gravitational acceleration. This deviation from the expected trajectory for a motionless object is attributed to the outgassing effect, a phenomenon commonly observed in comets but conspicuously absent in Oumuamua. Scientists speculate that the gaseous substances responsible for outgassing either depleted or were sealed within the object's interior. An innovative hypothesis was introduced at this point to spice things up. The solar sail hypothesis is a spacecraft propulsion method that harnesses radiation pressure from a star, like our Sun, to navigate through space. Unlike traditional spacecraft relying on chemical propulsion or ion drives, solar sails are purely passive, using the momentum carried by photons when they strike a reflective surface. So, how does this tie in with Oumuamua? According to the solar sail hypothesis, Oumuamua could be a flat, thin object, possibly a few meters wide and less than a millimeter thick, with a highly reflective surface. As it cruised close to the Sun, the intense solar radiation would have imparted a gentle but continuous thrust, influencing its trajectory. In the grand scheme of things, Oumuamua continues to defy easy explanations, keeping scientists and enthusiasts alike on the edge of their seats. As we uncover more about this celestial visitor, the mysteries of our universe unfold, one intergalactic puzzle piece at a time. Some speculative theories surround Oumuamua's peculiar characteristics. When sunlight photons strike the reflective surface of a solar sail, they impart a tiny amount of momentum. While each photon individually exerts a small force, the cumulative effect of countless photons over time generates enough thrust to accelerate the object. This acceleration, observed during Oumuamua's passage through our solar system, causes it to deviate from a purely gravitational trajectory. Now, the intriguing part of the solar sail theory is that it wouldn't produce a visible comet-like tail due to the absence of outgassing. Instead, thrust is generated purely through sunlight reflection. However, this theory comes with its challenges. Oumuamua's rotation and shape, including its tumbling motion, would need an explanation in the context of a solar sail. Additionally, it remains unclear how a solar sail of such dimensions could maintain its structural integrity under the stresses of interstellar travel. Another speculative theory explaining the behavior of the Oumuamua is the Hydrogen-Itzberg hypothesis. This proposal suggests that the object could be primarily composed of frozen hydrogen, the most abundant element in the universe. The idea is that in a distant and extremely cold region of its home star system, hydrogen gas could freeze into a solid, forming a dense and compact object. This Hydrogen-Itzberg, with an extremely low temperature potentially close to absolute zero, might explain its lack of a visibly comet-like tail as it approaches the Sun. Moreover, hydrogen ice is stable at low temperatures and wouldn't transition directly from solid to gas under typical solar heating conditions. You might be wondering, how can hydrogen ice accelerate Oumuamua without visible outgassing? Well, even though hydrogen is transparent to visible light, it can interact with higher energy ultraviolet and X-ray radiation. The absorption and re-emission of these high-energy photons could generate a small but consistent thrust, causing the object to accelerate. If Oumuamua were indeed a hydrogen iceberg, it would be a rare and unique object, explaining its distinctive characteristics differing from typical asteroids and comets. The impact of Oumuamua's hit on Earth. Now, let's shift gears and ponder the impact of Oumuamua if it were just space debris and not of extraterrestrial origin. A direct impact on Earth would spell global catastrophe. While the exact composition of Oumuamua is uncertain, It's likely a dense metallic or rocky object hurtling through space at immense speed. If it were to collide with Earth, the impact would be incredibly destructive. As it enters the atmosphere, the extreme friction would heat it up, potentially causing it to disintegrate or explode before reaching the surface. Considering its mass and velocity, the impact energy of Oumuamua is a critical factor in assessing its destructive potential. Impact energy quantifies the immense amount of energy released upon impact due to the object's mass and velocity. In simpler terms, kinetic energy. Oumuamua's mass, depending on its composition and size, could range from hundreds to thousands of tons. The elongated shape and estimated density suggest that a more massive object would carry significantly more energy, intensifying the potential devastation upon impact. Let's break this down in a more relatable context. A typical nuclear bomb's energy is measured in kilotons, equivalent to thousands of tons of TNT. The bomb dropped on Hiroshima in 1945 released energy equivalent to about 15 kilotons of TNT. Now consider Oumuamua. Even if it were a relatively small object, its impact would be measured in the megatons or gigatons of TNT equivalent. To put this into perspective, the largest nuclear bomb ever detonated, the Tsar Bomba by the Soviet Union, released energy equivalent to about 50 megatons of TNT. However, if Oumuamua were more massive, or traveling at a higher velocity, the impact energy could potentially reach into the teratons or trillions of tons, making it an event of unimaginable destructive power, a global killer. If such a force were to hit our planet, it would lead to a global extinction threat, a catastrophic event with the potential to wipe out a significant portion of life on Earth, including various species, and humans are not excluded. Throughout Earth's history, mass extinction events have occurred due to disastrous events like asteroid impacts. The most famous of these is the Cretaceous-Paleogene extinction event, which wiped out the dinosaurs about 66 million years ago. If Oumuamua were to impact Earth, it could trigger a similar mass extinction event. The immediate and long-term environmental damage would be devastating. Massive fires, tsunamis if it hit an ocean, earthquakes, loss of life, and destruction of ecosystems. The energy released upon impact would eject vast amounts of debris and dust into the atmosphere, leading to a nuclear winter effect. This could persist for months or even years, disrupting global climate patterns and severely impacting agriculture and food production. The combination of immediate devastation and prolonged climate upset would stress ecosystems, leading to a potential collapse. This domino effect could cause the extinction of one species, negatively impacting others. As for human survival, the challenges would be immense. Widespread destruction, severe injuries, trauma, and limited access to essential resources such as clean water, food, and shelter would be immediate concerns. Supply chains and infrastructure would be compromised as well, making it difficult for affected regions to receive assistance quickly. The nuclear winter effect would cause widespread crop failure, exacerbating food shortages. In an attempt to find resources in safer conditions, survivors may engage in mass migration, straining available resources further. Disease outbreaks would be a high risk, with compromised hygiene and medical care in crowded and resource-scarce environments. The breakdown of societal structures would add to the challenges of human survival, with the potential for civil unrest and violence as people compete for limited resources. To sustain human survival post-impact, communities would need to adapt to new environmental conditions, develop alternative food sources and sustainable shelter, and prioritize water purification and sanitation methods. Now, scientists from both government and private sectors have started actively monitoring and tracking near-Earth objects, assessing potential threats and developing strategies for planetary defense. Early detection and deflection methods are being researched to alter the course of celestial objects that might pose a danger to our planet. Where is Oumuamua now? It's an interesting fact that Oumuamua was silently making its way through our solar system, unbeknownst to astronomers until it had already ventured quite far. The saga begins with its perihelion, the closest point to the Sun, which Oumuamua reached on September 9, 2017, drawing within 23 million miles or 37 million kilometers of our star. The revelation of the interstellar object's existence came over a month later, on October 19, 2017, thanks to the keen eyes of University of Hawaii astronomer Rob Warwick. The discovery unfolded through observations made by the Panoramic Survey Telescope and Rapid Response System called PanSTARRS, an asteroid hunting system. At that moment, Oumuamua was already 21 million miles, which is about 33 million kilometers away from Earth, embarking on a trajectory that would lead it as close as 15 million miles or 24 million kilometers. To contextualize, this proximity is only about 60 times the average Earth-Moon distance. While this might seem like a huge distance in the vastness of space, it is a cosmic near-miss. Despite its brief cosmic rendezvous, Oumuamua left an indelible mark on our celestial neighborhood. As it charted its course out of the solar system, NASA noted that the sun's gravity propelled it to an astonishing velocity of 54.2 miles per second. Given its rapid retreat, astronomers had only a fleeting few weeks to observe it. The Hubble Space Telescope managed to track it for the longest duration, providing us with images capturing Oumuamua as a mere speck of light. Presently, Oumuamua is journeying towards the constellation Pegasus, navigating through the vastness beyond Neptune's orbit. As it passes through the Kuiper Belt, a ring of icy bodies encircling the solar system's edge, it gracefully glides out of our telescopic reach. A poignant realization settles in. Oumuamua, our interstellar guest, will never return to grace Earth with its presence. The cosmic traveler vanishes into the depths of space, leaving astronomers to ponder its mysteries from afar. Scientists, perspective on human extinction. Moving on, let's discuss the intricate threads of scientists' vision for humanity. Elon Musk, often portrayed as a modern-day oracle, has made a revelation that transcends our complacency, a prophecy urging us to heed the clarion call for the preservation of our civilization. Elon Musk's ominous warnings about impending doom and societal storms echo a genuine concern for the future. He draws attention to global birth rate trends, emphasizing a significant downward trajectory. The correlation between birth rates and societal structures, coupled with Musk's observation that higher income often correlates with fewer children, highlights complex dynamics influencing family planning decisions. His narrative takes a darker turn as he contemplates the potential outcomes of an impactful event on Earth. A global extinction threat, similar to historical mass extinction events triggered by disastrous events like asteroid impacts, becomes a focal point. The cascade of immediate and long-term environmental damage, including fires, tsunamis, earthquakes, and a nuclear winter effect, paints a grim picture. In the aftermath of such an event, Musk foresees immense challenges to human survival. Widespread destruction, limited access to essential resources, compromised supply chains, and the potential breakdown of societal structures would test the resilience of our species. The prospect of mass migration, heightened disease risks, and societal unrest add layers to the complexity of post-impact survival scenarios. Amid these dire warnings, Musk introduces a glimmer of hope. Scientists, both in the government and private sectors, actively monitor and track near-Earth objects, developing strategies for planetary defense. Early detection and deflection methods are under research to alter the course of celestial objects that might pose a danger to our planet. The likelihood of an asteroid collision with Earth is quite low, thanks to NASA's efforts in tracking and monitoring near-Earth asteroids. NASA has successfully identified and tracked 90% of these potentially hazardous asteroids that are at least half a mile wide. According to their assessments, none of these tracked asteroids pose a significant threat of colliding with our planet. However, there remains a possibility of larger asteroids that may be unknown to NASA. In the hypothetical scenario of a mile-wide asteroid hitting Earth, the impact would be catastrophic. Traveling at approximately 30,000 miles per hour, such an asteroid would unleash energy equivalent to a staggering 1 million megaton bomb. To truly pose an existential threat to life on Earth, though, an asteroid would need to be of massive proportions. Scientists estimate that an asteroid measuring 7 to 8 miles wide crashing into Earth could have devastating consequences. Upon impact, it would generate an immense dust plume enveloping the entire planet, blocking out sunlight and leading to a drastic rise in temperatures at the impact site. The aftermath of such an event would result in billions of casualties and severe damage to life on Earth. Nevertheless, scientists believe that some forms of life might survive the impact. NASA scientists emphasize that for a doomsday scenario, where all life on Earth is eradicated, an asteroid would need to be an astounding 60 miles wide. This showcases the resilience of life and the immense scale required for an asteroid impact to have a truly apocalyptic impact on our planet. While the chances of such catastrophic events are low in the near future, ongoing astronomical observations and advancements in asteroid detection technologies remain crucial for ensuring our preparedness and understanding of potential threats from space. Exploring other threats to human survival inevitably leads us to the realm of climate change, a pervasive phenomenon already wreaking havoc on various species globally. Climate change is more than just rising temperatures. It's an intricate web of issues encompassing food insecurity, water scarcity, and extreme weather events. These regional challenges, in turn, escalate into global threats to human survival. Luke Kemp, a researcher at the Center for the Study of Existential Risk, terms climate change as an existential risk multiplier. This implies that it doesn't act in isolation, but rather amplifies other threats to humanity on a global scale. Climate-induced food or water scarcity heightens international tensions, potentially triggering nuclear conflicts with catastrophic human consequences. This perspective underscores the complex interplay of factors contributing to existential risks. Kemp stresses the interconnectedness of existential risks, dismissing the notion of a singular catastrophic event causing mass extinction. History reveals that civilizational collapses are often the result of a confluence of various factors. The conventional idea of extinction, envisioning the sudden annihilation of all life on Earth, is just one scenario. A catastrophic event might leave a small surviving population, raising doubts about humanity's viability. Alternatively, it could target a specific segment of humanity, catalyzing global insecurity, conflict, and a gradual decline. The nuanced nature of extinction scenarios prompts us to consider risks that curtail our potential as a species. It's not solely about outright survival. Threats that hinder our progress, limit our spacefaring aspirations, or impede technological advancements are equally significant. Nelson emphasizes that risks challenging our fundamental purpose as a species, our drive to progress, pose substantial threats. One such risk is artificial intelligence, where the unintended consequences of intelligent robots could lead to widespread surveillance or surpass human capabilities physically and mentally. In essence, the exploration of existential risks broadens our understanding. It extends beyond immediate survival concerns to encompass threats that reshape our identity, redefine our purpose, and hinder our journey as a species. As we navigate these complex challenges, it becomes imperative to adopt a holistic approach to safeguard the continuity and potential of humanity. Our contribution to humanity preservation. In a reflective exploration of humanity's twilight, scientists have invited us to consider our roles in shaping civilization's fate. Delving into demographic perspectives, Elon Musk highlights the seemingly sparse cross-sectional area of humans, emphasizing that despite our perception of overpopulation, vast expanses of the Earth remain sparsely populated. He challenges extreme environmental viewpoints, asserting that humanity is not a plague but rather has the potential for sustainable coexistence. Musk also delves into the environmental movement, cautioning against overzealousness that deems humanity a problem. He challenges extreme views that suggest the Earth would be better off without people, expressing disbelief in such radical perspectives. He advocates for a balanced approach, acknowledging the importance of sustainable electricity generation, stationary batteries for intermittent energy sources like solar and wind, and electric transport as pillars for a sustainable future. In his contemplation of humanity's place on Earth amid climate change, he reflects on the resilience of life throughout Earth's tumultuous history. Referencing catastrophic events like meteorite impacts and supervolcanoes, Musk points out that life has endured even in extreme conditions, be it a snowball Earth or scorching heat. He draws attention to the myriad extinction events Earth has witnessed, highlighting that life, though evolving, has persisted. He emphasized that climate change may not threaten all life on Earth, but acknowledges the potential dislocation of humans, especially in low-lying countries facing rising sea levels. In his view, the key lies in understanding that life, even if not in the familiar human form, will endure. He encourages caution against complacency, urging a collective sense of urgency to transition towards sustainable energy. Thanks for watching. Make sure to subscribe to the channel and check out another of our interesting videos before you leave. See you on the other side.